Hi team, this is session 16, Linux Essential series, securing SSH with key-based authentication. SSH by default normal is it will ask you the username and password when you try to connect to a remote server. But since passwords, even if they are encrypted, if they travel, then definitely a third party network traffic sniffing tool can fetch it and ultimately it can be breached. So therefore we need to learn some way where you don't have to type the password. The authentication should happen with a key. So agenda of the session is securing SSH with key-based authentication, the commands, configuration commands, client configuration commands, basic encryption communication, private key, public key, and setting up these keys. So by the end of the session, demonstration wise, you will see what is a private public key concept, how it works, and how to use it in your day-to-day life on two systems, because I'm going to demonstrate these two public and private key concept. So we are going to work at it. We are going to see how the commands work without using the password. Simple key-based authentication. Securing SSH with key-based authentication. First, let me quickly demonstrate the key-based authentication so that you know what is the objective. A working key-based authentication. So these are the two systems which I have. If you see, this is my controller machine and this is my compute machine. This is actually a setup for my cloud. I'm working on a cloud and these two machines are set for that purpose. So I'm going to use these machines only for the demonstration. So from this machine, if I try to connect SSH controller, it will not going to ask me any password and then directly connect it to the controller. You see, I was working on compute, now I'm working on controller. This is without any password, without any username. This is called key-based authentication because I have set up the default key and exit. I can also type SSH username OS bash, which is there on the controller, and the controller IP address 10.0.0.11. I can type that also. Even in that case also it will work, because if you know, if the user is other than the current user, you can type the username followed by the host name. So again I'm connected. Same way from here also I can try SSH compute 1. So again I'm connected to the compute 1 from here without any username and password, and this is also because of the keys are set, SSH keys are set, and that is what the agenda of the session is, and how to connect we'll learn in this session. So as SSH is an important tool for administering systems remotely, precisely that's what I use for my production systems also. You know, I have servers, you know, we are managing websites, so even I manage my servers using SSH. It is important to understand the basics of how it encrypts the communication between a client and SSH server, and to create public-private key pair so connections won't even put your passwords at risk. But first, it may be helpful to review some basic information about SSH commands and configuration file. That is why I emphasize that we need to have some basic background, some theory, and some knowledge about the concept. For example, configuration commands. It makes sense to have the commands. For example, SSH command itself is not working. The server is not responding. So how can we make sure that server respond, and what is the guarantee that server will respond to any SSH request? For that, server has something called SSH daemon, the secure shell daemon. The secure shell daemon is a program which runs in the background. If it is not running, you simply cannot connect. So that this is a daemon service which must be running to receive inbound secure shell client request. If the daemon is not running, there is no point connecting. All the commands, everything will fail, because SSH will not work at least. because it will not respond to any SSH request. Second is SSH agent. This is a program to hold private keys used for digital signature algorithm DSA or elliptic curve DSA, ECDSA, or reverse Shamir and Adman RSA authentication. These are three algorithms. You don't have to remember these names. DSA, RSA, ECDSA are the three names of algorithms for encryption. You don't use all of them. You use one of them, and default is good enough. Default is RSA. So you don't even need to remember these names if you don't want to remember them. But knowing that there are three different algorithms is good to have. The idea is that SSH agent command is started in the beginning of X session, X window session, or a login session, and other programs are started as the client to the SSH agent program. Again, I have never used, and you may not be requiring, is this SSH agent command as such, because this is just a program to hold the keys. SSH add private key identities to the authentication agent, SSH agent. So SSH add is mandatory before you work with SSH agent, because you need to add the private keys to the authentication agent, SSH agent. Ultimate learning, our session agenda is SSH, secure shell command SSH. To make it work with key based authentication, you need a private key on the client and a public key on the server. So simple. You need a key. You need a private public key pair in order to work. And then you need to copy the public key to the remote server. Copy the public key, for example, id_rsa.pub. Public key will end with .pub. And all the keys are added to authorized keys of the user. Of the user means the client from where the user is going to connect. Let's take a look at. Let's take a look. So there's a folder called .ssh. In that folder you will find the keys. Alright, so .ssh, and you see the keys here. Authorized keys means this file will have the key for other users who will try to connect to this machine from other systems. What does it mean? It means we are working on compute node. Authorized key will have the key of controller node, because controller may try to connect to this machine. Means controller key from the controller machine need to be put into authorized keys. Reverse direction, let's look at what will be there in the authorized key of this file on the controller node. It will have the key of compute node. So compute node will have keys of controller node. Controller node will have key of compute node. So I need your key in order to enter your house. You need my key to enter in my house. That is the concept. And these are the keys. These are the key file. ID RSA. If the file does not end with a .pub, that means it's a private key. ID RSA, this is a private key. This is for this client. ID pub. This is the public key. That means this key is sent to the controller node. And which means if I see ID RSA PUB, this key is not for the controller node. This key is basically from the compute node. Same way, the key on this system, the key from this machine is sent on the other computer. So we exchange the key, and the keys are added. If you look at, let me simply type cat ID underscore RSA dot pub. This is the key. If you look at, this is the key of compute node. Alright. Now if I use cat command and to display the content of this, right, authorized keys, you see that the keys are added. look at this key, the key from the controller node. So key from the controller node is added here. This is the key from the controller node. This is key from controller node. This is key from controller node. So from controller node we have added 3 times. We have different keys from the controller node. Same way on this machine, if you use cat authorized keys, you will see the key from the compute node. This is a key from the compute node. Alright, so we can add keys from the compute node. We have done it multiple times. If you see the keys are same, you may wonder why we have multiple times. Nothing, I just continue trying the multiple times. So every time you copy, it will be copied to this file. So there is no harm even if you have multiple copies of the same key. But in this case, they are not actually, keys are not same. They appear to be same, but they are not same. Why? Look at the ending. This key end with this, and this key end with the different number. So they are not same keys. They are different keys. Because I generated them. In this case also, are they same? They are not same. But yes, these two keys are same. If you look at these two keys are same, and this one 2 PS, no, they are not same. So these two keys are same. Other 2 keys are different. So basically we generate the key, we send them to the other client who will connect to this machine. I'm going to delete all these files to show you and to make it work. In fact, I'm going to remove the folder itself, rm-rf.ssh. I'm deleting everything on this machine as well as this controller as well as compute node. cd rm-rf.ssh. I have removed everything. All the keys, private key, public key, everything is removed. Now if I try to connect with SSH, compute node, it will ask me, first it will ask me that yes, it will generate a key. It will, you are asking me is cannot be trusted. So this warning is displayed. Are you sure you want to connect? If I say yes, and only then it will ask me the password. So I have to type the password and then it will connect. Now it is connected. So this is the normal mechanism of connecting it without SSH key. It asks me the username, it asks me the password. It did not ask me the username because I did not specify. By default it will connect with the username which is being used to log in the current machine. Right, now the connection is closed. So we are good to start. We don't have any keys right now. We have removed all the keys and we are going to set up them again in this session. So let's understand the concept now. SSH is the command which I demonstrated. This is the command which will generate the key. SSH-keygen. This is a utility that creates private public key pair for SSH authentication. SSH keygen command -t and key type, because we can have key type as RSA, DSA and ECDSA. You can specify any type based on your requirement. By default it will generate RSA keys. SSH copy ID. This is the script which will copy the public key to the target remote system, which I told you that in order to connect you need the public key to be copied to the remote system to which you want to connect. So how you are going to transfer those keys? You can use SSH copy ID. So this is the command. So important sequence of command is: number 1, we will verify SSH daemon is running or not. Number 2, we will generate the key. Number 3, we will copy the key. Number 3. Number 4, we will use the command to connect. This is the 4 sequence. Step number 1, SSH daemon, verify it is running or not. Step number 2, generate the keys. Step number 3, SSH copy ID to copy the keys to the remote location. So we are going to use the same sequence to connect and to create the working system. SSH client configuration file. System configured with SSH include configuration files in 2 different directories. For local system, basic SSH configuration files are stored into etc SSH directory, and for configuration files in each user's home directory with the name .ssh, which I demonstrated, which I showed to you, .ssh folder. Those files configure how the given user is allowed to connect to the remote server. When DSA, when DSA, ECDSA or RSA keys are included, the .ssh subdirectory include these files. One is the authorized keys. I told you, I demonstrated the content, I showed the content of this file also when the file was existing before I deleted the directory. This file include the list of public keys from remote systems, from remote users. For example, we are going to create keys on both the systems and we are going to transfer the keys to the remote system. Means from the controller I am going to transfer key to compute. From compute one I am going to transfer the keys to the controller node. The system users and names are listed at the end of each public key copied to this file. And these are the key names. I told you that if you don't end with the file with .pub, that means it is a private key. So ID underscore ECDSA, this is the default name, though you can specify other name. So this is a private key ECDSA, this is public key ECDSA, this is private key RSA, this is public key RSA. Same way you can have a ID underscore DSA, ID underscore DSA dot pub. So that is the default names, though you can have your own names also. Known host will contain the public host keys from the remote system. So these are the configuration files which you will find in your .ssh folder. Not all of them, maybe these two of them, maybe these two of them, or depending on which keys you have generated. Client configuration files. The first time a user logs into the system, it is prompted to accept the public key, which I showed when I tried to connect to my remote system. I was asked I was prompted to confirm that yes, the public key of the remote system is there and you have to accept it. ECDSA protocol is used by default in encrypted traffic. The corresponding public key on the remote server is located into etc ssh host ECDSA public.pub and is added to the client in its local .ssh known host file. So where this key is to be added to this. This is default without any key generated. I'm not talking about key based authentication. We are talking about a normal SSH client configuration. Basic encryption communication. Basic encryption in computer networking normally require a private key and a public key. Private key is stored by the owner and the public key is sent to the third party to whom you want to give the rights to connect to your machine. A user can encrypt a message using his private key while a third party can decrypt a message with corresponding public key. This also works in reverse. SSH protocols work in a similar way. The server sends the copy of its public key to the client and this key is used by the client to decrypt the message or traffic and set up secure communication channel. So first thing is we need to verify and we need to create the key. Encryption keys are based on random numbers. The numbers are so large, typically 2048 bits for RSA key or even maybe more. Even you can specify the size. The chance of someone will break into the server system will at least a PC is practically impossible. Private and public encryption keys are based on matched set of these random numbers. Private keys, they must be secure. Key-based authentication relies on private key that is accessible only to the user owner of that key in .ssh subdirectory in the home directory. To authenticate a user, the server sends to the client a challenge which is requested to perform an encryption operation that requires knowledge of the private key. Once the server receives a response to its challenge from the client, it will be able to decrypt the message and prove the user identity is genuine. Public key. Public keys are publicly available. Public keys are designed to be copied to the user.ssh subdirectories in a file named authorized keys. The permission for private keys are set to 600 and for public keys are 644 because they are to be copied, they are to be sent, they have to be read only. The permissions for .ssh directory should be 700 And this is the kind of, this is example of a key. Just it is 1024, by the way. This is very small. This is the minimum size of the key, 1024 bit. Can you remember this number? And this is just 1/4 of the real life keys, because real life we use 8 KB or 4 KB keys. And this is just 1024. This is 1 KB. So imagining, trying to remember these kind of big numbers. Set up private key, public key pair. Now we are good on the job. Directly without looking at the theoretical part, we have already discussed this part. SSH keygen, the size 8 bit, 8 KB, 8192 is 8 KB. By default, you don't have to specify if you want to generate the default size, you simply type SSH keygen, and this is what am I going to do. So first thing, and the first two commands I'm demonstrating now. First is verifying whether SSH the daemon is running or not. So systemctl status SSH D. So it is running or not. I need to verify this. This is the first step. If the daemon is not running, your SSH will not work. The first thing is first thing first. So systemctl status SSH D. The daemon is running. You don't do anything else other than this verification. Verification done. Now we'll generate the key. So SSH hyphen keygen, and simply this is sufficient in order to generate the default keys. So generating private public key pair, and by default it is showing, I told you that it will generate RSA key pair, and enter the file name to which to save the key. You can save it in the default ID underscore RSA, or you can type a name. I want to keep the default name. And passphrase, I'm not specifying any passphrase. If I specify before connecting, it will ask me the passphrase also. I don't want to protect my key with passphrase, though I can do that. Enter the same passphrase again, and the key is generated. Now if you go to .ssh folder, and you will see the files here, id underscore RSA and id underscore RSA.pub. The two keys are generated. These are the two keys which are generated, and these keys need to be sent to the remote system in order to allow the remote system to connect. So simply I'm going to transfer these keys to the remote system. That is going to be my next command. So first command is done. Let's move on and we'll show the second command also. First two commands are demonstrated. So we have generated the key, SSH keygen. You want to generate a DSA type key, you can specify with -t. You want to specify 8 KB size, you can specify with -b. Once the keys are generated, you need to copy them. So SSH copy ID -i and the key name, and where you want to copy them. So let's copy them, because we need to copy them. The moment we'll copy them, it will with -i option copy commands without -i option transmit the most recently created public key. So it is not mandatory to specify -i option if you have only one set of keys available, right? So let's use SSH copy ID to copy the key, and we will see on the remote machine that this file is created. Let's take a look. Okay, now we can go to the home directory. You don't need to be in that directory. SSH hyphen copy ID, and which machine you want to copy. OS bash is the username, at controller. You need to specify the username at hostname so that you actually ensure that you are copied to the right user to the right system. So I is not required if you are copying only one key, and that is the latest and the default. -i is required if you want to specify the different key name and if you have more keys. So it is asking same question, warning, that is going to be ensure that it is authenticity of this cannot be established because you are trying to connect for the first time. Whenever you connect for the first time, it will ask you this. Password of the controller it is asking, because we are doing it for the first time. So it is asking me the password. Number of keys added 1. Now try logging in with the machine with SSH controller. So that means now we can connect by simply using the name SSH, and now it is connected. That's all. That's how easy it is. So once you connect, because we transfer the key and we are connected from this machine to the controller, we generated the key and we are connected, and that's easy. That's how easy it is. We are working on the controller now. Connection closed. Same thing we can do now. If you want to take a look at what is there in .ssh folder now, here what we have is the authorized keys. The key which is generated on the compute node is available here, and the known host. So known host means when it asked, it gave me that warning that this authenticity cannot be established. That warning came because there was no known host. That value was not entered. The details were not entered into this file. Now this file exists. Now it will not ask me every time. And that key, the public key, is added to this file. If you want to see that, you can use cat authorized keys, and the key which I generated on the compute node is added here. This is the key which I generated just now, and in front of you I copied this to this. So SSH copy ID moved the keys or copied the key to this system. Alright. Now you see that this key have been copied. If I use cat command, cat ID underscore RSA, this is the key. This is my public key. Oh, sorry, this is private key. Public keys dot pub, and this is the public key which was copied. Look at this. You can see it is same key ending with 55. This is the same key. Right? That's the concept of private public key pair. You generate the key, you send the key, and then you don't require user ID password. So I use SSH copy ID. I use OS bash as controller, and I copied the key, and they were added to my authorized key file. And after that I was able to connect. I was able to connect with using SSH username, and there was no username and no password, and simply I connected with this. Had you given a passphrase while creating the key, a console or pop-up would have come for asking the username, that password. Though I did not specify, so it did not ask me. That's all for this session. Thank you so much. I hope you enjoyed it.